The second one is the theory of failures, maximum principal strain theory. Now, a, a point in a body will fail when either the maximum principal strain reaches a critical value determined by tension test or the minimum principal strain test. Maximum principal strain reaches a critical value determined by compression test of the material of the body. In other words, if the failure values of the principal strains in tension and compression for two-dimensional stresses system. Stresses system equals sigma yp by n. Now it the strain, yield point strain by the factor of safety. That is epsilon 1 greater than equal to sigma epsilon yp by 2 yp by n. This is actually sigma by epsilon yp by 2 n. This is epsilon 1 greater than equal to epsilon yp by n, where epsilon yp is equal to yield point strain. Okay. Now this is the stress strain relationship for biaxial stress strain system. Say epsilon 1 is equal to 1 by e sigma 1 minus mu sigma 2, where mu is the Poisson's ratio and epsilon 2 is equal to 1 by e sigma 2 minus mu sigma 1. For uniaxial stress system, only one direction stress, so epsilon is equal to sigma by e. Epsilon is equal to sigma by e. Sigma is the stress by Young modulus of elasticity. Now epsilon greater than equal to epsilon yp is equal to sigma yp by e into n. So sigma by e is equal to greater than equal to sigma yp by en. So from here you will get directly here sigma greater than equal to sigma yp by n. So that is the failure stress is equal to sigma maximum is maximum stress is equal to sigma yield point stress by n is the factor of safety. Now epsilon x, in the similarity here from here, epsilon is equal to epsilon yp by n. Epsilon stands for the strain. Okay, n is the factor of safety. This is the actually the equation. Okay, now I am giving the total picture of this. Okay, now this is now epsilon maximum strength is equal to yield point strength by n. So this is the mathematical expression for Saint Venant's maximum principal strain theory. Now I will not explain it again. This is known. Okay, okay, okay. Now first quadrant. Okay, second quadrant. Okay, third quadrant. Okay, fourth quadrant. Okay, now the above gives satisfactory results for brittle material like cast iron, and in civil engineering this may be also the concrete, but here we are using cast iron to satisfy these equations. And for soil mechanics there will be more Coulomb theory for shear stress. Okay, now you just take this one